Okay, let's start with 9. So the given condition is 8,000 money to spend 8,000 per month, and it costs 75 to produce each camera. The question is asking how many cameras must be made each month to have an average cost per unit of 100. Okay, so this question is a little bit tricky, but we can set up our equation like this. So the first part is $8,000 overhead plus $75 each camera. How many cameras? Let's see, we need to see many cameras to have an average, which means equal equation, average of $100 per camera. Okay, so that's the equation we need to make. Average cost, which means the overhead is being averaged to each camera. You know, whatever the overhead is being averaged to every camera. So the $100 with every cost. So the first part is the cost is separated. We have two parts of cost. One cost is $8,000, like one time, right? 1 month. We don't know what the cost is. It could be rent, it could be anything. But then plus $75 for each camera. So this is one way to calculate the cost of camera, the cost of making many cameras. On the other side, that is to have an average cost per unit of 100, which means whatever the cost is being averaged out to each camera. So if we produce many cameras, it would be 100 times C. So that's the equation we need to make. Now we just solve this linear equation, right? We have 100 C minus 75 C equals to 8,000. Well, 100 C minus 75 C, that's 25 C. 25 C equals to 8,000. So C equals to 8,000 divided by 25. Well, how do we divide by this? Think about the multiply 4 on both sides, right? Let me do this trick for you. We multiply 4 with 25, that's 100. Then we multiply 8,000 with 4, that's 32,000. So it's easier to do the calculation, right? Then C equals divided by 100 on both sides, so 320. So 320 cameras needs to be made to make an average cost of $100 for $8,000 per month. Extra cost of $75 to make each camera. Okay, that's for this question. Let's see, number 10. Your taxi charges you a fixed charge of $5 per ride, plus $1, well, this is per ride, plus $1 for every mile, rate. So this is asking how many miles. It did not ask for how many rides, right? Ask for how many miles must your taxi trip be. It's talking about one ride, just one trip. For the average cost per mile is 1.2. Similar to 9. Okay, so we set up equation like this. $5 for each ride, right? Plus $1 for each mile. How many miles needs to be? Let's say M miles. For average cost of 1.2 M. We can make sense of this, you know, similar reason as 9. So the left-hand side is calculating by one-time fixed. for each ride. Then each mile charges for $1. So that's a cost. Well, another way to calculate is saying, whatever the cost is for each ride, $5 in this case, being averaged out to every miles. So then the average cost per mile is 1.2. So the rest is to solve this linear equation. So 1.2 m minus 1m minus m equals to 5. That means 0.2 m equals to 5. Right? So let me use a trick for you again. Let's multiply by 5 on both sides. So 0.2 times 5 is 1. Right? So m equals to 25. Okay. You can multiply by 5 on both sides of this equation. 0.2 times 5, that's 10. But then you have this decimal point, put it behind 1, before 0, in between of 1 and 0, in the middle of the 10, so that becomes 1. And your right-hand side multiplied by 5, that becomes 25. Now let's see 11. Texting plan charges you $10 per month plus 10 cents per text message. So how many text messages, let's see, T many, you need per month in order for the average cost per text to be 0.15. Exactly same, same equation we need to make. So $10 is a one-time charge. 0.1 is for each texting. Let's see, you have T many textings. Then average out the 0.15 T. Then we combine like terms. We use 0.15 T minus 0.1 T, we got a 0.05 T equals to 10. Multiply 20 on both sides, because 0.05 times 20 give us 1. Then T equals to 2,000. You could divide it, right? If you do 10 divided by 0.05, that's fine. Let me show you how to do that. Okay, if you want to do both sides divided by 0.05. First, we want to get rid of these decimals. How do we get rid of the decimals? We multiply by 100 over 100. Because 0.05 times 100, it's a 5. Okay. So then the denominator, when we multiply by 100 with the denominator becomes 5. The numerator 10 times 100, that becomes 1,000. 1,000, oh, what did I do? Right, multiply by 100, multiply by 100. Then 1,000 divided by 5, that's 200. That's 200, not 2,000. I made a mistake here, right? Because 10 times 20 is not 10 times 200. 10 times 20, you should get 200. So 200 text messages. Let's see, 12. It takes K 10 hours to pick 40 bushels of apples. So Margie can pick the same amount, which means also this much apples in 15 hours. How long would it take them to pick the same amount of apples if they work together? Okay, we could use this 40 divided by 10. Or remember work done, we can treat this work done as 1. Because you see, everywhere is the same amount. In the end, it will cancel out. Doesn't matter if you use 40, if you use 1. In the end, the solution is the same. But instead of doing 40, we just do 1. because we don't want to get into big numbers to calculate. So then the speed of K picking apples is 1/10. Work done divided by hours. For them to work together, that means add that speed. Okay. And then 1/15. So then this will be the speed of both working together. Let's call this V. You can call speed, you can call anything else. How do we multiply those two fractions? So the key is to multiply those two fractions. Well, we see the common denominator is 30, right? Because 10 times 3 is 30, 15 times 2 is 30. So we want to make these two have a common denominator. We want to multiply 3/3 for the first one. We want to multiply 2/2 for the second one. Now we have a common denominator of 30. Once we have a common denominator 30, we just perform the operation with new numerators. The operation is a plus. So 3 plus 2, that's 5. Or we can simplify this. Okay. That becomes 1/6. So this is the speed. This is the rate. When they work together, that's how fast when they work together. But the question is asking time. How long, if they work together, how long it would take them to finish the work? So we have to do time equals to work done divided by the speed. In this case, is 1/1/6. So 3 layers of fractions. That's 1 times the inverse of 1/6, which is 6/1, which is just 6. So it will take them 6 hours to work together. So when they work together, it only take them 6 hours to finish picking the 40 bushels of apples. Let's look at 13. Ben can paint a room in 14 hours. Job done, right? Ben and Jake work together, can paint the same room in 9 hours. So that means the together V in this case is 1/9. When they work together, the speed is 1/9. And when Ben works all by himself, his speed is 1/14. So the question is asking, how long would it take Jake? What's Jake's speed? Let's call Jake's speed 1/J. Right. When they work together, the speed is adding up, right? So working together, speed is 1/9. Ben working speed is 1/14. J working speed, let's call it 1/J. So we need to solve for this J. So we see 1/J equals to, we move 1/14 to the other side, equals to the speed when they work together, subtract the speed of Ben, 1/14. Now we need to figure out the common denominator. The common denominator is just 9 times 14. We multiply this one with 14/14. We multiply this one with 9/9. Then we have a common denominator of 9 times 14. So common denominator is 9 times 14. And the numerator, we have 14 minus 9, which is 5. 14 times 9, 4 times 9, 36. 10 times 9, 90. 90 plus 36, 126. So that's a 5/126. Now that's 1/J. We want to find a J. So 1/J will flip, and we flip. So J equals 126 divided by 5. Then we have to convert it into hours. So we flip 1 over j. We got j over 1, just j. The speed of j work all by himself. Then we flip this. So that's 126 divided by 5. And we need to convert this into hours and then the minutes. How do we do that? 125 can be divided by 5. So we split 126 into 125 plus 1. Then divided by 5. 125 divided by 5 is 25. Let me type too hard to write. 25 hours, right? Then 25 is 25 hours. Then 1 over 5 hour, we need to convert 1 over 5 hour into minutes. What do we do? We multiply by 60 because each hour has 60 minutes. Then we see 60 is 60 over 1. 60 divided by 5, that's 12 minutes. So 25 hours and 12 minutes. Okay, so that's the answer for this one. So it would take, so Ben needs 14 hours to finish to paint the room. And together they can finish in 9 hours. But if Jake work all by himself, he needs 25 hours. Wow, that's a lot, huh? And 12 minutes. Let's see 14. One pipe can fill a pool in 9 hours. Job done again. A second pipe can fill the same pool in 6 hours. So the speed of the first pipe is 1 over 9. The speed of second pipe is 1 over 6. How long will it take both pipes to fill 3/4 of the tank? Okay, the tricky part is this, right? 3/4 of the tank. Well, let's see to finish the job. So let's try to find the finish the job first. So it would be, we want to find the speed when the two pipes are working together. That would be 1 over 9 plus 1 over 6. And the common denominator is 18 in this case. Okay. So multiply 2 over 2. We multiply 3 over 3 in order to have a common denominator of 18. Then adding those 2, we have 2 plus 3, that's 5 over 18. That's the speed. That's the rate when the two pipes working together. Okay. And how long it takes to fill the whole tank? That would be T equals to 1 over job done over the speed of working together, which is 5 over 18. 3 layers, 1 divided by 5 over 18, which means 1 multiplied by 18 over 5. So that's 18 over 5. Now we only want to finish 3/4. 3/4, which we could use the job done here. If we want, we could start from here. T equals to 3 over 4 divided by, let's just start from here. 3 over 4 multiplied by 1, because job done is 1. We're treating object, but we only have 1 3/4 to be done. So we use 3 over 4 divided by 5 over 8. That's 3 over 4 multiplied by its inverse of 5 over 18, which is 18 over 5. Right. Well, multiplication of the fraction, which is the multiply numerator with the numerator, denominator with the denominator. And then we see 18 and 4 can simplify, right? Because both have factor of 2. We simplify 18 divided by 2, that's 9. 4 divided by 2, that's 2. Now 3 times 9, 27. 2 times 5, that's 10. So 27 is 20 plus 7. So we get a 2 hours, right? 2 hours. And the 7 over 10 minutes, what is the 7 over 10 minutes? 7 over 10 times 60, because 7 over 10 is in hours, times 60. 60 divided by 10, that's just 6. 6 times 7, 42 minutes. All right. So we'll take both pipes to fill 3/4 of the tank with using 2 hours and 42 minutes. So this is question is a little bit tricky. Let's say 15. A dump truck travels 300 miles on the freeway in the same amount keyword time it travels 170 miles on a country dirt road. Okay, so speed for truck is distance divided by time. We don't know time, let's call time t. Then on the country road, distance 175, same amount of time. So it's same as t. So it's still divided by t. So we have these two speed. Right? If the rate you can understand as the speed of the truck is 25 miles per hour less on the dirt road than on the highway. Freeway means highway in here. Okay, we just equal freeway and the highway. So that means this one is more than the second one, 25 miles per hour. So this is the speed on highway. This is the speed on country road. They are differ by 25 miles per hour. So we have a rational equation. Now, how do we solve this equation? We have a common denominator, right? T. So 300 minus 175, that's 125. So we have 125 over t equals to 25. 25, we can think as 25 over 1. Then we cross multiply. 1 times 125 equals t times 25. So we have 25t equals 125. Divided by 25 on both sides. So t equals to 5. Equals to 5. So it takes some 5 hours on each road. So now we know t. The question is asking, find its rate on the highway. Right? Find its rate on the highway. What is its rate on the highway? So 300 divided by t. So we do 300 divided by 5, which is 60 miles per hour. 60 miles per hour. Yes, 15. This is 16. Derek drove 18 miles to the airport to pick up his sister and then return home. Same distance, right? He goes to the airport, he comes back home. He goes to the airport from home, then he drives back from the airport to home. So we see 18 miles multiplied by 2, right? Because it's a round trip. On the return trip, he drove 2 times faster than he did on the trip there. What does it mean? So if the speed when he go to is v, then when he comes back, his speed is 2v, because 2 times faster. If his total driving time was 1 hour, so going to and come back, he only used 1 hour for those round trip. What was his driving speed to and from the airport? All right, remember we have time equals to distance divided by speed, right? So when he goes to airport, his speed is 18 divided by v. We don't know his speed, right? We're trying to find, so let's call his speed v when he go to airport. So he used the time distance divided by his speed, so 18 divided by v. And when he comes back, how long did he use? Same distance, but his speed was twice faster. His speed was 2v. So this is time going to airport. This is time coming back from the airport. So what is the time totally he used? He used 1 hour. So we made a rational equation. Now we need to solve. 18 divided by 9 is 9. Right. So now we have common denominator. Both denominators are v. 18 plus 9 is 27. So 27 over v equals to 1. But 1 is 1 over 1. We cross multiply. 1 times 27 is 27. 1 times v is v. So v equals to 27. So when he goes to the airport, his speed is 27. When he comes back, it doubles the speed, which is 54. 2 times 27, 54. Let's see 17. John started a race running at a speed of 6 miles per hour. Half hour later, Kyle started running the race from the same start position at a speed of 7 miles per hour. So when will Kyle catch up to John? So distance, right? Let's see this starting point, right? John started first. So let's call this J. Started first. And his speed was 6 miles per hour. So 1 hour later, so this is 1 hour. So he started 1 hour. 1 hour later, what's his, Kyle started. So why can I write on it? 1 hour later, so Kyle started. So the difference is time. The difference is 1 hour, is in time. So if we want to make an equation with time, right, we can find the time. So when will Kyle catch up to John? So the rest of time is the same. The distance will be the same, catch up, right? Just imagine, Kyle, let me use red color. Kyle started late, but Kyle goes faster. So at a certain point, he reaches, he catches up with John. Even John started earlier, but his speed is slower. So when Kyle catch up with John, that means they travel the same distance. So we want to make an equation with distance. The left-hand side might be John, the distance of John traveled, right? The right-hand side will be Kyle's. So let's go back to find. So John's speed is 6 miles per hour, right? So he started earlier. So he has 6 times 1 hour, because that's the distance from here to here. 6 times 1, that's the distance, speed of 6 times 1 hour earlier. So 6 times 1, which is just 6. And the rest of the distance we don't know, right? We don't know, but it's the same. So it's just, let's see t, right? T time. So that would be plus 6 times 1 just 6. So 6 plus 6t. 6t, right? From here, so this time John used is the same as the time this time is John used, right? Then what about Kyle? Kyle's distance. Kyle started running, Kyle's speed is 7 miles. So that's Kyle's distance, Kyle's speed multiplied by time. So we just solve the equation, right? We move 6t to other side. 7t minus 6t, this is t. So t equals 6. So 6 hours later, Kyle catch up with John. Let's say 18. Varies directly, direct variation as x. That means direct variation means y equals to a constant multiplied by x. When y is 18, when y is 84, equals x is 12, 12k, right? That means k equals to 84 divided by 12. 84 divided by 12, how much? Let me simplify with this. Okay, let's divide by 4 first. I have 3. Divide by 4, I have 21. 7, right? 21 divided by 3 is 7. So k equals 7, which means, okay, I can change this k now. So y equals to 7x. So the question is asking, when x is 17, what's y? So y equals to 7 times 17, which is 7 times 7, 49. 10 times 7, 70. 70 plus 49, 119. Right. 19. A varies inversely as B. So we use equation A equals to K divided by B, or A times B equals to K, right? So when A is 42, A is 42, A is 42, when B is 4, so times B is 4 equals to K, which means K equals to 4 times 2, that's 8. 4 times 40, that's 16, 168. So now we want to find A when B is 6. So put it back in. 6A equals to 168. Okay, so we divide by 6. We divide by 6. Let's see, let's first divide by 2 first. So we divide by 2, 6 becomes 3. Divide by 2, this becomes 84. 84 divided by 3. 84 divided by 3, that's 28. So the answer is 28. Let's see, 20. The amount of gallons of gasoline a car uses varies directly again. Y equals to AX formula, use this formula. If the car uses 15 gallons of gasoline, so what's the amount of gallon of gasoline? So this is the amount of gasoline, right? Varies directly to how many miles. X is how many miles it travels. So if a car uses 15 gallons of gasoline, the Y equals to 15. While traveling for 400 miles, that's 400 K. So let's solve for K first. So we divide by 400 on both sides. Let's see what is K. Let's simplify first. Simplify with 5. So this I get 3. Divided by 5, this I get 80. So K equals 3 divided by 80. A fraction. Now the question is asking, how many gallons of gasoline will A use if it travels 550 miles? So that means y equals to 3/80 times 550. Let me type 550 first. Multiply by 3, multiply by 3/80. Because 3/80 is my k. Well, simplify with 10, divide 550 by 10, divide 80 by 10, because 550 is numerator, right? Now 3 times 55, that's 165, divided by 8, right? So this is how many gallons? How many gallons? You could use calculator to approximate. So this is the answer. Let's see, 21. Amanda's wedges vary directly. Again, we want to use y equals to kx formula. To the number of hours. So y is money, x is time, t. If her wages for 5 hours are $29.75, we have to deal with decimal. 29.75 cents, $29.75 equals to 5 hours times k. So k, we just divided by 5. So k equals to 29.75 divided by 5. 5 times 5, 25. 29 minus 25, we have 4. Then carry on the decimal point. 47, we want to put a 9 there. Then 47 minus 45, that's 2. 25, that's 5. So k equals 5.95. So our equation is 5.95 times x. So k is 5.95. Now the question is asking, how much will they be for 30 hours? So x is 30 now. So y equals to 5.95 times 30. We just have to multiply those two numbers, right? 3 times 5.95, what do we get? We get 16. So 3 times 5, 15. Carry on 1. 3 times 9, 27, 28. Then carry 3 times 9, 27, carry on 2. 3 times 5, 15 plus 2, that's 17. So 1780, because that's a 0 with 3. But we have 2 decimal points. So we take 2 places to put our decimal point. So it's 17. So the money is $17.80. Let's see, 22. So 22, saying the price per person of renting a bus varies inversely. We know we want to use x times y equals the k formula. With the number of people, right? So price is one variable, number of people is another variable. It costs $12 per person if 60 people rent a bus. That means k equals to 12 times 60, which is 720. So get our formula, y equals to 720, y times x, or x times y equals to 720. Now the question is asking, how much will it cost? Asking for the money per person if 78 people rent the bus. So plug in, so that means 70ax or 70ay, doesn't matter which variable you want to use, equals to 720. So x equals to 720 divided by 78. 720 divided by 78. Let's simplify by 2. Right? So 720 divided by 2, that's 360. 78 divided by 2, 78, 39. Right. Then we see this, can this be divided by 3? No. Oh, yes, because this is 360. So we divide by 3. We get a 120 for the numerator. 360 divided by 3, 120. Denominator 39 divided by 3, get 13. Now cannot be simplified anymore. So we have to round it out. This, we can get decimals to get this into dollars and cents. All right, so how do we do that? I would do this. Looks like long division. 120 divided by 13. I think I can put a 9 over there. Let me see. If I put a 9, 3 times 9, 27. No, that's too big. I have to put an 8. So that's 4. 3 times 8, 24. Carry on to 1 times 8, 8 plus 2, 104. That's 120, right? Oh, I have 16. Yes, I can put a 9. So let me put a 9. 3 times 9, 27. Oh, right. That's only 111.7. So 120 minus 117. I have 3 left. Now I put a decimal here. So I put 0 here. Then I can only put a 2 here. Right, 26. Subtract, I get a 4. Right, 40, I can put a 3 here. Yes, 339. Right, but I still have remainder 1. So just carry on 1. Carry on, carry to 3. Change 3 to be 4. So that would cost per person $9.24. Because the money only up to cents. That's 22. Let's see 23. The length of a violin string varies inversely. Again, length of violin, let's use L as variable. As a frequency, let's use F, just like a 1x, okay, equals to K. Of its vibration, a violin string 7 inches long vibrates at a frequency of 490. So that means K equals to 7 times 490, which equals to, let's see, 7 times 9, 63. So I have 0, I'm going to do backwards. 3, right? Then I carry 6 to the next one. 4 times 7, 28. 28 plus 6, 34. So that's 3, 4, 30. So that means the length of the violin times the frequency of the vibration equals to 3430. Now the question is asking, what is the frequency F of a 10 inches long string? Just plug in F. So 10 inches long string, right, which is the length 10. We're looking for F equals to 3430. So it's divided by 10 on both sides. So F equals to 343. And that's it. That's our answer for 23. Okay, I'm gonna stop right here. I'm gonna make another video for 24 and maybe some other questions.